In this video, I will explain you about refraction. Now first we will see what is a reflection. In reflection, we have a plane mirror. An incident ray is coming in one direction. After reflection, it is going in another direction, obeying the laws of reflection. But one thing is sure here, that the whole process is happening in the same medium. So here, if the medium is air, then the incident ray is passing through air, and after reflection that is going back to air itself. If this is water, incident ray is going through water, and after reflection it is returned back to the same medium. Now in the refraction, there are two mediums involved. Now I will explain you the definition of refraction. When light enters a different medium, there is a change in velocity. This is very important and lot of students forget about this fact. There is a change in velocity and direction. This phenomenon is called as refraction. Now simply I would say that if the light ray, so this is a medium, say for example air, and this is another medium, water. Now when a light ray is passing from air to water, so both are transparent medium, so it will allow, this medium will allow the water to pass through, the incident ray to pass through, because water is a transparent medium. So from air, ray would pass to water. Now what will happen in this case? In this case, in air, the velocity of light is approximately 3 into 10 power 8 meters per second. But in the case of water, it would become 2 into 10 power 8 meters per second. See, velocity of light has got changed. Okay, so here also refraction is occurring, but there is no change in direction. So generally we would say that refraction is change in direction of the light ray, the way we have learned in the smaller classes. We have this one air and another medium, glass. Now when light ray enters in one direction, first what we will do, we will draw the normal, and here the light ray would bend towards the normal. So it was supposed to travel in this direction, but it is now bent to this direction. Now this is the angle of incident that the incident ray makes with the normal, and this is the angle of refraction, the angle that refracted ray, this is refracted ray, and this is incident ray. Now the angle that the refracted ray makes with the normal is called as angle of refraction. Now this we have already learned that when it travels from one medium to another medium, the direction of the light ray would be bent, or direction of light ray would be changed. So here this is the direction that is changed to here, or I can say there is a bending of light ray. So it was going in this direction, now it is bent to this direction. Okay, so here in this case there is both the changes. One is change in direction and another one is change in velocity of light ray. Here there is no change in direction because the incident ray has came along the direction of normal. Here if this is the surface, the direction of the normal is here. So for example, if this is the case, this is water and this is glass. Okay, so what will happen? Light ray, if it is coming in this direction, after refraction it would go in the same direction. There is no change in direction, but there is change in velocity. Here it is traveling with a velocity of 3 into 10 power 8 meters per second, but here it is traveling with 2 into 10 power 8 meters per second. Okay, so this is a very important concept. Now we'll see what factors defines the bending power. So certain medium would be bending it lot more, and certain medium would be bending it less. Even certain medium would be bending in this direction, certain other medium would be bending in different angle. Now through which angle the medium would be bending the light ray is defined by a certain parameter that is called as refractive index. Okay, now what is refractive index? I will explain it here. Refractive index refractive index. So this is defined for a medium, that is velocity of light in space divided by velocity of light in the medium. Now we know that velocity of light is the same for space. The value is 3 into 10 power 8 meters per second. C is 3 into 10 power 8 meters per second. This is constant. Now what is changing is velocity of light in medium. So that is refractive index. Now refractive index of water is equal to refractive index of water is equal to velocity of light in space divided by velocity of light in water. So this value, velocity of light in space divided by velocity of light in water, this value is proven as 1.33. And what would be the unit and dimension? This would be unitless, dimensionless quantity, because it is velocity divided by velocity. It's a ratio, so it will have no unit, no dimension. Okay, now next thing is refractive index of glass, that is velocity of light in space divided by velocity of light in glass, and this value is 1.5. Now if someone is asking what is velocity of light in glass, you can easily get the value that you know velocity of light in space. So velocity of light in glass, transfer this to here and bring 1.5 here. So velocity of light in glass is equal to this divided by 1.5. So C divided by 1.5, which is C is equal to 3 into 10 power 8 meters per second divided by 1.5. So these two will cancel and this would become 2. 2 into 10 power 8 meters per second would be the answer. So if you know refractive index, you can also find the velocity of light in that particular medium. So that is simply C divided by refractive index of that medium would be equal to velocity of light in a particular medium. So that is another equation, but that is not necessary to learn, but you have to learn this equation. Refractive index is equal to C divided by, C is nothing but velocity of light in space divided by velocity of light in medium. Now I will explain you what will happen when light ray travel from one medium to another medium. So we have seen that refractive index of water is equal to 1.33 and refractive index of glass is equal to 1.5. Now we know from this that refractive index of glass is greater than refractive index of water. Very important this is. Okay, now two cases. One is from glass it is entering to water, and next case from water it is entering to glass. Okay, now an incident ray is coming in this direction. Now this is the normal. What will happen to the ray? Actually it was supposed to go in this direction. Would it bend in this direction, that is away from the normal or towards the normal? Compare these two values of refractive index. Glass has got 1.5 and water has got 1.33. So refractive index of water is less as compared to glass. So what I can say, that it has got less bending power, or it would move in this direction. So this is the direction. It would move away from the away from the normal. Now here in this case, from water to glass, so from 1.33 to 1.5, higher refractive index. So what will happen if a light ray is coming in this direction? It was supposed to travel in this direction, but as glass is having 1.5 refractive index, it has got more bending power. So here the ray would be bent towards the normal. So this is the angle of incident. This is the angle of refraction. This is I and this is R here. Here in this case, this is I and this is R. Now we will compare these two. So now in refraction there are two mediums involved, right? So just compare these two medium and its refractive index. The one that has got lower refractive index is called as rarer medium. Now in this case, glass and water, which one is rarer medium? Glass is having 1.5 and this is 1.33. So it has got lesser refractive index. So this is rarer medium, and this is denser medium, and in this case water 1.33 and this is 1.5. So this is rarer medium, and this is glass 1.5, denser medium. So I can now simplify that when the light ray is traveling from denser medium to rarer medium, after refraction, the refracted ray move away from the normal. So here in this case, from denser to rarer, after refraction, refracted ray move away from the normal. Now from rarer to denser, what will happen? After refraction, refracted ray move towards the normal. See, here ray towards the normal, here ray which was supposed to go in this direction away from the normal. This is the normal here. Next thing, in denser medium 1.5, it is having higher refractive index. Now we know refractive index is equal to C by V. Now how the refractive index would be higher? If the velocity is lower. Okay, now here 1.5 is higher because glass has got lower velocity. Here in water light has got higher velocity. So I can say that in this case light is traveling from, or refracted ray is having higher velocity. Is that correct? Because water has got lesser refractive index. So if this value is less, which means V is more. C cannot change. So V is more. So water has, here refracted ray is having more velocity as compared to the incident ray. Now here in this case, refracted ray, see here glass has got higher refractive index, which means when this value will become higher when this is lower. So I can say that refracted ray is having lower velocity as compared to incident ray. So these two are first point of comparison. Next point of comparison. Next point is here I is less than R, or I can say R is greater than I. That is the conclusion from point number 1. Here in this case, this one is R, right? So R is less than I. So here R is less than I. R is more than I, which means refracted ray move away from the normal. R is less than I means refracted ray move towards the normal. So these are very important. Okay. Next, what we are going to consider is Snell's law. Okay. That is very important in the case of refraction. Okay. Snell's law. According to Snell's law, first I am going to take a consideration of a ray which is from rarer to denser. Okay, so rarer medium means medium 1, denser medium means medium 2. Okay, now if a light ray coming in this direction, when it was supposed to move in this direction, this is the normal, but after refraction it will move in this direction. So this is I, this is R. According to Snell's law, it is saying that sin I by sin R is equal to mu 2 divided by mu 1. This is the Snell's law. Okay, sin I divided by sin R is equal to mu 2 divided by mu 1. This we have already proved in the chapter wave optics. You can go and refer the video where I have proved with the help of Huygens wave theory that sin I by sin R is equal to mu 2 by mu 1. Mu 2 means the refractive index of medium 2 and mu 1 is the refractive index of medium 1. So I would say that sin I by sin R is equal to, what is mu 2? C divided by velocity of light in medium 2 divided by C divided by velocity of light in medium 1. So this is my mu 2 and this is my mu 1. Okay, so this C would cancel and V1 would come to the top, that would become V1 by V2. So this implies that sin I by sin R is equal to V1 divided by V2. So mu 2 divided by mu 1 can also be written as mu 2 1, or this can also be written as mu 2 1. Both are the representation of Snell's law. So generally we would say mu 2 1, which is mu 2 divided by mu 1. Okay, this is Snell's law. So, and one more thing, that incident ray, refracted ray and normal would lies on the same plane. So this ratio would be satisfied along with the fact that incident ray, normal and refracted ray would be on the same plane. Okay, now we will consider a case where I have kept a slab in a medium. Okay, so I have kept a slab in a medium. It's a glass slab, and let's say this is air. So what will happen? This is the normal. Now if light ray is coming in this direction, this was supposed to move in this direction, but after refraction that will move towards, because air has got almost a refractive index of 1, here glass has got a refractive index of 1.5, this is denser medium, so after refraction it would move towards the normal. Now this would reach here. Now at here it is one more interface, glass to air. So it's a glass piece, right? It's a glass piece. So what will happen? I have to mark the denser, sorry, I have to mark the normal, and after refraction it would move in this direction. Why in this direction? Because it is from denser medium to rarer medium. So from denser to rarer it would move away from the normal. So this ray was supposed to travel in this direction, but now it just moved away from the normal. So this is R and this is I and this is again R. Now we will see the cases of these two rays. What will happen to these two rays? So first I have to see what is this angle. So I know that sin I by sin R. So at this interface 1, that is in between from air to glass, I have applied Snell's law. So sin I by sin R is equal to refractive index of glass divided by refractive index of air. Okay. Now, here at this angle, at this place, let's say I don't know this angle R1. Okay. This is angle. These two angles have to be equal. If this is R, this angle also have to be R, because these two are parallel lines. If these two are parallel lines, these are alternate angle. So let's say I am going to consider this as angle I1. I don't know if this is I1, if I1 is equal to I or a different value. Okay, so at this interface from glass to water, on applying Snell's law, sin, what is angle of incident? Here it should be R itself, parallel alternate angle, sin R divided by sin, what is this angle? I1 is equal to refractive index of second medium, what is that? Air, divided by refractive index of glass. What we have seen is, see here it is glass divided by air, here it is air divided by glass, just the inverse. So I can say that if this is 1 and if this is 2, I can say 1 by 2 is equal to 1. Just find the inverse, just take the inverse of this equation. This would become glass divided by air. So I can say that glass divided by air, just take the inverse. So on taking the inverse, sin I1 divided by sin R is equal to here glass divided by air itself. So sin I divided by sin R. So sin R will cancel. So sin I1 is equal to sin I. So if for two angles sin values are same, then I have to say that I1 is equal to I, which means these two angles would be equal. So what does this mean? That after reflection, these ray, the incident ray and also the refracted ray, after double refraction, one refraction and second refraction, they would move parallel to each other. And one more conclusion this is saying, that instead of light going in this direction, if I am sending the light in this direction, this would retrace the path, same path it would follow. So from here, then here, then here. Okay, so this is the case. So I can say one more thing from here. This gives the conclusion that mu of 1, 2 is equal to mu1 divided by mu2, and mu 2, 1 is equal to mu2 divided by mu1. So just take the inverse. So 1 by, this implies that 1 by mu21 is equal to inverse of this, mu1 divided by mu2 and mu1 divided by mu2. So this value is equal to this value. So first thing, that 1 by or mu21 is equal to 1 by mu12. Very, very important relation this one is. In triple refraction, what is happening? This is medium 1 and medium 2 and medium 3 and back to medium 1. Okay. Now from air, light ray is coming. This is the normal. Medium 2, I am assuming that this one is denser, this is more denser than rarer. So this is from rarer to denser. So what will happen? Light ray would bend towards. Okay. Now in the next case, so it was supposed to move in this direction, it is now bent towards. Now in this case, again from denser to more denser. So I can say that it was supposed to travel in this direction. Instead of that, it is bent towards. Okay, actually this line is bit bent more than this line. Okay, just assume in that way, or I would make in this way. So it is now bent in this way. Now this is supposed to travel in this direction. It is now more bent in this direction. Yeah, it is now kind of clear. Now this is the incident ray. It is bent away in this direction. This is angle of incident I1. Okay, this is R1. Now as these two lines are parallel, this R1 should be equal to the same R1, and this is R2. And as these two lines are parallel, alternate angle, this also should be R2, and this would be incident ray. So that would be I. Okay, I am keeping the same notation in the same medium. So it's medium 1, medium 1. So I am going to use I. So I1 I could say. So apply Snell's law here in this interface. So sin I divided by sin R is equal to, so here sin R1, right? Sin R1 is equal to, this is medium 1, medium 2. So mu 2 divided by mu 1. Okay. Now in this interface I am applying, that is from 1 to 2 I have applied. Now from 2 to 3 I am applying. So sin, what is the incident ray? I1, sorry, R1. This is R1, right? Sin R1 divided by sin R2 is equal to M3 divided by, sorry, mu 3 divided by mu 2. So refractive index of second medium. This is the second medium compared to this. So mu 3 divided by mu 2. Now in between 3 to 3 back to 1. So from 3 to 1, next refraction occurs here. So here sin, what is the incident ray? R2. Sin R2 divided by sin, what is this? I3 is equal to, this is the next medium, second medium, mu 3 divided by mu 2, refractive index of 2. Now what I am going to do is, this is equation number 1, equation number 2, equation number 3. On multiplying 1 with 2 and then with 3, I have one equation. So multiply these 3 together. So sin I by sin R1 into sin R1 divided by sin R2 into sin R3 divided by, sorry, sin R2 divided by sin I3 is equal to, sin I3 is equal to mu 2 divided by mu 1 into mu 3 divided by mu 2 into mu 3, sorry, here mu 2 by 1, 3 by 2 into, this would be mu 1. Okay, second medium. Okay, here at this interface I made a mistake. This is not mu 3, this is medium 1. So this is mu 1, then first medium is mu 3. Okay, I made a mistake here. This value sin R2 divided by sin I3 is second media mu 1 divided by first media mu 3. This is medium number 3. So that is mu 1 divided by mu 3. So and one more thing, that we know that this I1, this I and this I would be equal, because after refraction these two rays would be parallel to each other. This I have proved previously. So this would be equal to I1 itself from the proof before, I itself. So what will happen? Sin I cancelled, sin R1 cancelled, sin R2 cancelled. Okay, sin R2 cancelled. So from here mu 2 cancelled, and mu 1 cancelled, mu 3 cancelled. So this is simply 1 is equal to 1. Now we got here, we have cancelled everything and we have 1 remaining. We have cancelled everything and we have 1 remaining. So the equation is correct. LHS is equal to RHS. Now instead of representing it in this way, what I am going to represent is mu 2 divided by mu 1 is nothing but mu 2 1, and mu3 divided by mu2 is nothing but mu31. Sorry, mu2 divided by mu2 is mu32. Now mu1 divided by mu3 is mu13. Okay, so there is no cancellation. I have just replaced this as this, and I have replaced this as this, and I have replaced this as this. So on the LHS it is 1 itself. Now I can say that this would be equal to 1, or I can say that mu21 into mu32 into mu13 is equal to 1, or mu32 is equal to 1 by mu21 into mu13. And I have told you in the previous example that mu12 can be written as 1 by mu21. So same thing I am going to do with mu13. So what is mu13? This implies that mu13 is equal to 1 by mu31. Okay, now this replacement I am making for this 1 by mu13. So what is 1 by, just bring 13 here, so 1 by mu13 is mu31. Okay, so from here I could say that 1 by, take this here, 1 by, and transfer this also here, so 1 by mu13 I have transferred this to here, that is equal to mu31. Okay, now this replacement 1 by mu13 is equal to 1 by mu13 is equal to mu31 I am going to make here. So that will be is equal to mu32 is equal to 1 by mu13 is mu31 divided by mu21. See, another important relation. So this I would take with an example. Let's say this is air and this one is water and this one is glass. Okay, what is mu32? That is refractive index of 3. 3 is this, glass with respect to water is equal to refractive index of, what is mu31? Glass with respect to air, divided by refractive index of 2, water with respect to air, See, this is the equation. It's a very, very important relation. Okay, that's all. Thank you.